Alright, so today we're going to be doing a lesson on quadratic models. This is the last section in chapter 2 before we review and test. So first thing we need to look at is how to classify different scatter plots. So just looking at these scatter plots, we need to be able to determine whether the data is better modeled by a linear model, a quadratic model, or neither. Alright, so this first one, we just look at the points and determine, does it look like it's best modeling to be modeled by a straight line, by a quadratic, which remember looks like a U shape or a parabola, or is it neither? So the first one that we've got, those dots obviously look like they're forming a straight line. So we would say that this one would be a linear model. The second one, you can see it looks like they're making a slight curve, almost part of a parabola. So for that one, we would say quadratic. And this last one right here, it's not really a linear shape, and it's not really a U shape or even part of a U shape. It's kind of just a up and down curve, moving all over the place. So this one will be neither. So first you need to be able to just identify them by the shape. I'm not going to spend much more time on this. Just make sure you all understand a straight line's linear, parabola or U shape is quadratic, and something different is going to be neither. So let's actually practice doing some quadratic models. So we've done linear models already. So there's the whole process we took notes on way back in chapter 1. I believe it was towards the very end of chapter 1. We did linear models. So this is a very similar process. I'm not going to walk you through all those steps again. You have them in your notes from chapter 1, but they're very similar, just with one slight exception. So here's what we're going to do. We want to figure out, using this study that compares the speed that you drive with the mileage of a car. We got these results down here in this table, and they want us to use a calculator to create a scatter plot. Use the regression feature to find a model that fits the data and figure out the speed that the mileage is the greatest. Right? So these are really valuable problems to find greatest amounts, the maximum amount of profit, different things like that whenever you have a quadratic model. So we're going to do the same thing we did with linear models. We're going to go to the stat plot and plug in the numbers first. So it's hit stat, edit, and we need to plug in these values. So we're going to plug in all the speed, the x values for L1. So 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75. And then the y value, we're going to plug all those in, 22.3, 25.5, 27.5, 29, 28.7, 29.9, 30.4, 30.2, 30, 28.8, 27.4, 25.3, and 23.3. Okay, of course, make sure that they line up. Make sure you don't have an extra element. They stop at the same spot. So we assume we've typed them in right. We might have hit a button wrong. You can always go back and check. I'm not going to take time to do that. All right, so now you hit y equals, and we want to go up and hit plot 1 and hit enter to turn the stat plot on. All right, so that's the next step, and we want to go to that plot. So remember, we want to zoom. Which one are we going to pick? We're going to pick zoom stat to zoom to our stat plot. So we hit zoom stat, and we see this right here. Now the question is, we want to ask ourselves, does that look like a linear model or a quadratic model or neither? Well, it looks to me like a parabola, right? So we would say that's a quadratic model. So once we determine which model we're going to use, we can clear out of the graph and go back to stat. Now we want to go over to calculate. Okay, again, these are the same steps we did for linear models, except the only difference now is that since the graph did not look linear, it looked quadratic, we're going to pick quadratic regression. Before we picked linear regression. Now we're going to pick quadratic regression. Make sure your list 1 and list 2 are L1 and L2, right? And wherever your X and Y's are, if maybe you have L2 and L3, make sure you change those to L2 and L3. Also on your stat plot, if you had L2 and L3, you'll want to go to your stat plot and make sure your X list right here is L2 and your Y list is L3. So those all have to coincide. All right, so I'm going to go back to calculate, quadratic regression's 5. Make sure all that's entered correctly, and then hit calculate. Okay, so here's my model. Y equals ax squared, A, I'm going to plug in negative 0.0082, and we can round this off to any real decimal place that you want to use, unless it tells you some specific value to use. Let's say that we just round it off to two significant digits, right? So these two zeros aren't significant. The 0.82 is, so we're going to round it off to negative 0.0082 x squared plus 0.75 x, so that's two sig figs, and then on C be plus 13.46. All right, so that's what we'll put in for our model. So our model, we could say, f of x is going to equal negative 0.0082 x squared plus 0.75x plus 13.46. And that's a pretty good representation. We've got two decimal places that are significant in each of our terms, so that's a good model right there. Now the last step, it told us it wanted us to then approximate the speed at which the mileage is the greatest. So to do that, we want to plot our line. Okay, so we're going to graph this line that we just found. Now remember, the way to do that is a little tricky. You're going to go to y equals, just like you would normally to graph a line, but now you're going to pick vars. Okay, we went through all this with linears. It's the same for quadratics. Pick statistics, number 5, all right, and then go over to EQ and pick regression equation, and it'll plug that equation that we just found into y equals, as long as it's still on your home screen. All right, now we graph it, and we get a parabola going through the middle of those points. Okay, so now we can use that to find the maximum by calculating the maximum, and we know how to calculate a maximum. Hit second, calculate, 4 for maximum. It says left bound, so remember we go left of the maximum, and then right bound, move the cursor over to the right side of the maximum, hit enter, and then it says guess, hit enter one more time, and it'll give us the maximum. So the maximum mileage that we're going to get is 30.4, 4 if you want to round it to the hundredths. 30.44 is the maximum, and that's going to happen at a speed of 45.46 miles per hour. So the question had approximate the speed at which the mileage is the greatest. Remember, x right here is speed, so the mileage is the greatest at 45.46 miles per hour. So that would be our answer for C part. All right, so I'm going to go ahead and pause the video, let you guys try the next problem on your own, and then we'll go over it. All right, so we get all our numbers entered here. I know it takes a long time to enter these, and most of the problems you have on a quiz or test are not going to be like this, but in real life, if you're ever doing a scientific study or data analysis, sometimes you can have to have decimals this long to have to type in. Okay, and it can be a pain because you can mess up one decimal that throws the whole thing off, so you just got to be careful and double check it. And I know it takes a lot of time and it stinks, but that's what you got to do. All right, so you plug them in, and then we go to our graph. Again, you probably want to make sure you delete the function that we had graphed on the last problem. So go to your graph, hit zoom 9, and you can see this shape. It looks like a part of a parabola, a quadratic. So we look like we have a quadratic function. So to calculate the model, we're going to go to Stat, Calculate, and pick Quadratic Regression. Make sure your L1, L2, all that stuff is right. Enter it in. And now we get this as our model. So our model we're going to say is f of x. Of course, you can use whatever you want for your y value. You can use y. So we're going to say y equals, and a is negative 15.45 x squared. And we're going to subtract 1.30 times x, and then add on 5.23. So that's what we could write down for our model. Now the last part says to figure out the time when the ball hits the ground. So x is time. We forgot what is x when the height is 0, right? Because if we want the ball to hit the ground, that means the height is 0. So let's graph the function. So we get y equals vars, and then pick statistics, which is number 5. Go over to equation and pick the first thing, regression equation. It'll plug that equation in. We can graph it and see a good representation of those points. Now we need to figure out, we need to zoom out and see where that line crosses the x-axis, right? So that graph's going to come down and hit the x-axis. That's where the height is 0, right? The height's decreasing all the way down through here, and bam, right there's where it's 0. So we need to figure that out. So you can calculate that on the calculator, hit second calculate, and those values that cross the x-axis are called zeros. So we're going to pick 0, and then you treat it just like you do with left bound and right bound with a maximum. You would go to your x-intercept, but then it says left bound, so go left of it a couple clicks, hit enter. It says right bound, so then go over to the right of it a couple clicks and hit enter. It says guess, hit enter one more time. So our 0 happens at when x is 0.5414. So that means the time when the ball is going to hit the ground, right, is going to be at the time 0.541 seconds. Okay, because it's in seconds is what we're counting in. So, but a little bit over half a second is when the ball is going to hit the ground if we drop it from a height of 5.25 feet. All right, so now let's see about what we got to do when we need to choose a model. So we don't know which model to use. Okay, so let's look at this table. All right, so let me get this table. Let's see, it's back here. All right, so what we want to do is graph this data and then determine what is the best model, which model fits the data the best. So same thing we've been doing, but we're gonna clear out the graph that's already on there. And let's go back to our stat menu. Okay, now we can clear out all this stuff. Okay, you can go through and delete them all one at a time. I believe if you go up here and hit delete, just deletes L1. That's not what you want it to do. I think if you hit clear and then drop back down, it'll just delete all the data out. Okay, so you can always do that. Just delete, go up here and hit clear, and then go back down, and it'll clear out all the data. If you hit delete, it's going to delete your L1. So now this calculator's not got an L1. You got to change everything to L2 and L3. But that's probably good practice. So let's do 2000, 2001, 2002, 2003, 2004. You get the idea, all the way up to 2007. And then over here, 39.4, 39, 38.5, 37.5, 37, 36.3, 35.4, and 33.9. So we graph all these. Okay, now what you want to do is, of course, make sure your stat plot's on and hit zoom stat. Mine says dimension mismatch, means I typed something in wrong or the columns don't match up. So let's go back and double check. Oh, it's because I have L2 and L3 now. So when I do my stat plot, I need to make sure my stat plot up here, go to second stat plot. See, I've got L1, L2. I need to make sure those match L2 and L3. So I need to go here, and then down here on the calculator, see it says L2 in blue and L2, L3 in blue. So I need to change those. Hit second L2, and then change to second L3. Now, when I hit zoom stat, it should work just fine. Okay, so let's quit out of that. Zoom 9. Now we can look in and see our stat. Okay, so when we look at it, it's kind of hard to tell whether it's more a straight line or more a quadratic. So when you have one like this, you need to rely on what r squared is. So I'm going to show you how to figure out r squared. What you'll want to do is before you calculate your regression line, you'll want to go to mode, okay, scroll down, and make sure that you turn on stat diagnostics. Okay, stat diagnostics, it's off. We need to turn that on. That way when we calculate our regression equation, it'll give us a number that tells us how strong of a correlation that is. So now we hit stat calculate. Let's do a linear regression first, see if it looks linear. Notice mine are L1, L2. I need to change these to L2 and L3 or I'll get another dimension mismatch. Now I can calculate and it gives me, so what I'm looking for here is r squared. Notice my r squared is 0.971 for a linear regression. So now the higher that is, the closer it is to 1, then the better correlation I have on my data. Okay, so let's calculate now a quadratic and see if it's better. So hit stat, calculate, quadratic regression, number 5, and make sure it's L2 and L3 on mine. Okay, so r squared here is 0.9922. So that's even better than what it was for a linear. So I would say that the best model for this one is a quadratic model. All right, so for this one I would pick quadratic. So that's pretty much it. You just graph each of them, look at your r squared, and see which one's better. And that's the model that you would use. Now if we hit vars on this one, graph our regression equation, okay, we can see the regression line that goes through it. And then we could use it to estimate, if it said, they just want us to find the model, determine which one was best. But maybe now they say, okay, well, what about in the year, 2018? How much is there going to be, right? How many gallons per person of soft drinks are going to be consumed? So then we could hit second table and go out to the year 2018. So of course this is the year 0, the year 1. So a little trick on your table when you're looking at it, if you hit the plus button and then tell it 100 or 1,000, then you can make it count the x coordinates by 1,000. So 0, 1,000, 2,000. So I'll scroll down to 2,000, and I'll go back to hit plus 1 to make it count by ones again, starting at 2,000. So that's a quick way to scroll through instead of having to scroll through 2,000 numbers. I'll scroll down to 2018, and I see 14.6 is the amount of soft drinks that's consumed this year according to this data. So it looks like it's dropping. Okay, so just some tricks again to change that the way it's counting on here. Okay, you hit the plus button on the calculator, and then when that pops up, okay, you would hit 100 or 1,000, whatever you want it to count by. You hit enter, and now it'll start counting by those values: 2018, 3018, 4018. So I go back down to like 18 and hit +1 and hit enter, and now it'll start counting by ones again. All right. So some quick way to scroll through on the calculator. All right, let me know if you guys have any questions on choosing a model. Here's a few problems for you to practice this, and I'll come around and answer questions as you need it. Appreciate your all's attention. Thanks.